Good afternoon, pre-calc students. We're going to go over the solutions to the mock ncfe, and in the interest of time, I'm going over each section where the correct answer is boxed, and I have my solutions out on the item, so this is already written out, and just I'll making a video because a verbal explanation might be useful to you. For the first problem, it says what transformations have occurred to create the function f of x is equal to 3 times x cubed minus 4 from the original function g of x is equal to x cubed. First thing we want to do for functions transformation is look at the core basics of our function transformation, which is going to be a times the quantity of outside the function times b, which is inside the function, of x minus c cubed plus d. Notice b is inside the function because it's inside the parentheses that's being cubed. D is completely outside the function. Our first step that I see when we are looking at the function is that the minus 4 is completely outside the function, and the minus 4 is going to be, based on the function transformations d, it's going to be a shift up or down, and it does exactly what you think it does. It shifts the function down 4. So this is outside the function, so it's a vertical shift, and it's minus 4, so it's shift down 4. So that immediately allows us to eliminate options A and B, because they said move up 4. Now I have to see whether it's a horizontal stretch or a vertical stretch. Well, this 3 is completely outside the function, and the reason why we know it's outside the function is because the 3 is not being cubed. It's not inside the core part of the function that's being cubed. So because it's outside, it's vertical, and it's a stretch, and it does exactly what you think it's going to do. It's going to be a vertical stretch by a factor of 3. So we have a vertical stretch by a factor of 3, downshift 4, that's option D. Let's move on to problem number 2. An object is launched straight upward from the ground level with initial velocity of 50 feet per second. The height h in feet above ground level of the object t sections after launch is given by the function h of t, so this is the function for the height of the function, is equal to negative 16t squared plus 50t. At approximately what value of t will the object have a height of 28.0 feet and will be traveling downward? Now we have to plug in 28 because 28 is going to be equal to negative 16t squared plus 50t because 28 is our height. And what we do is we set the function equal to 0, and now this is a quadratic function that we can evaluate. This does not factor nicely, but we can use the quadratic formula. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So we have negative 50 plus or minus the square root of 50 squared minus 4 times negative 16 minus 28 all over 2 minus 16. The next step is I evaluated that term, the square root, in the calculator, and I did 2 times negative 16 is negative 32. So I had negative 50 over negative 32 plus or minus 26 over negative 32. Further simplified, in my calculator, 50 over negative 32 was 1.56. And I had plus or minus 26 over negative 32 was 8.8125. I want to make a note here. This is just going to have you conceptualize the word problem. But for adding and subtracting, the object is going to go up first, then come down. So the function's the height, the object launching straight up, it's going to first go up and then come back down. So the later time is going to be the time what we're doing it when the object is coming downward, because we're trying to find the height of the object, not when it says 28 feet, but it's 28 feet and traveling downward. So out of our 2 times when you evaluate the quadratic formula, it's going to be 2.375. 2.375, the closest answer is approximately 2.39, so we choose answer A. Another way to do this that I'm not showing you is you can just plug in this initial function into your calculator and evaluate the zeros. Okay? But you have to be careful. You have to be an expert at using your calculator in order to do that. So let me grab the calculator myself for the next one. number 3, it says, what is the range of the function f of x is equal to negative 5 minus 2 times x plus 3 squared? And I just rewrote that as negative 2 times x plus 3 minus 5. And you guys just need to know about parabolas from our conics unit. And so we have y is equal to negative 2 times x plus 3 squared minus 5. So the vertex of this downward facing parabola, because it has that negative sign, that negative sign tells us that we're downward facing, is negative 3, negative 5, which means that the highest point of the parabola is negative 5. All other y values are below that. Graphing the calculator, this is what we got when we graphed it, so you can graph it too. And so we say the range of this function is from negative infinity to negative 5, because all y values are either less than negative 5 and hit their highest point at negative 5, and then keep on going back down to y values that are below negative 5. So our range is from negative infinity to negative 5. This requires you to use your calculator, requires you to understand range, it requires you to understand parabolas inside and out. Going on to problem number 4. So, a wind, this is a word problem, so we gotta be able to read and understand the word problem. A wind that is blowing from the northwest towards the southeast can be represented by a vector. The vector has an eastward component and a southward component. The eastward component has a magnitude of 5 miles per hour, and the southward component has a magnitude of 15 miles per hour. In what direction is the wind blowing? So our horizontal component, if we have our directions that are going to be east, north, west, and south, east is going to be actually positive, so our horizontal component is 5, and our vertical component is southward, so that's going to be not 15, but negative 15. All right? So our theta is equal to the inverse tangent of negative 15 over 5. Do it in your head. Negative 15 over 5 is going to simplify to 3. So we just need to find the inverse tangent of 3. Excuse me. And we want to switch to degree mode. Mission critical that we are in degree mode because our answers are in degrees. So the answer is 71 point... Oh, I'm sorry. Negative 15 over 5 is going to simplify to negative 3. So make sure you put into calculator, right? The inverse tangent of negative 3 is negative 71.56. So looking at our answer choices, all answer choices are in east of south. So when we draw our coordinate direction, we start at south and we're going towards the east direction, so we're going here. So that's kind of what we're drawing here. We're going from south to the east. So if we have negative 71.56, that means we're starting at 0 and we're going down counterclockwise 71.56. So our direction that's east of south, this value, this angle right here, that theta is going to be equal to 90 minus 71.56. So 90 minus that answer is going to be equal to 18.43. And so that's going to be option D. D is the best answer. So this requires you to find the angle from the horizontal and vertical components of a vector, and then also requires you to use inverse tangent, requires you to keep track of your positive and negative signs, and additionally, it's going to require you to understand Cartesian coordinates, directional coordinates. All right. What value of x satisfies the equation log base 3 of x minus 4 equals 2? I'm not even using my calculator for this. I swoosh the logarithm. If we understand what logarithms and exponentials and the relationships with them, we can say that 3 to the second power equals x minus 4. 3 squared is 9. 9 equals x minus 4. Add 4 to each side. 13 is equal to x. That is answer choice D. Hopefully you can get that answer in 30 seconds to give you time for harder problems. Number 6. I know some of you guys had a challenge on number 6. A man is standing on level ground 50 feet away from the wall of a building. He looks up at a window on the building. The angle of elevation to the bottom of the window is 28.5 degrees. He then looks up to the top of the building. The angle of elevation to the top of the building is 35 degrees. What is the approximate distance between the bottom of the window and the top of the building? That's going to be 7.9 feet. That's the answer. Let's see how we get there. When we draw the building, y1 is the distance from the bottom of the building to the bottom of the window. y2 is the distance from the bottom of the building to the top of the building. The distance from the bottom to the window to the top of the building is going to be y2 minus y1. I have the drawing here and it conceptually right here. So let me finish this problem, right? Then, so y2 minus y1 is going to be 50 times the tangent of 35 minus 50 times the tangent of 28.5. So why is that? Well, we drew it right here. You have the building, you have 50 feet, then we have our man. The angle of elevation here is 28.5. The angle of elevation is here, and the horizontal distance is 50 feet. So if the tangent of these triangles, of a triangle is opposite over adjacent, the tangent of 28.5 is going to be, let's call this y1 over 50. And the tangent of 35 is going to be y2 over 50. So you just multiply 50 by each side, and we get 50 times the tangent of 35 equals y2. 50 times the tangent of 28.5 equals y1. And so then we have y2 minus y1 is 50 over tangent of 35 minus 50 of tangent of 28.5. And if we can draw and conceptualize this problem, we know that y2 minus y1 gets us our answer. So let's make sure we are in degree mode. We are. And then we just write 50 times the tangent of 35 minus 50 times the tangent of 28.5, because we understand it conceptually, and now we're just plugging in the final answer in the calculator to get it. And our answer is 7.86. That's going to be closest to 7.9. That's answer choice B. I'm going to stop the video, and next problem 7 is going to be coming up next.